بسم الله الرحمن الرحيم. In the last part, we discussed the derivative function and we gave the definition of the derivative function. And we said that f of, or the derivative of the function, f prime of x is given by the limit f of x plus h minus f of x divided by h, where h goes to 0. They say this is the definition of the derivative. And this will give me the general, this will give me the derivative of the function. But sometimes we need to check whether the function is differentiable at a given point. Not in general, I will give just a specific point. I mean to check the function that is differentiable or not. So we said that a function is, or f is said to be differentiable at some point x0 if the limit let's say to the limit instead of x, it will be f of x0 over h, where h goes to 0 exists. If this limit exists, then we say that the function is differentiable at that given point. For example, check whether the function f of x equal to absolute value of x is differentiable at x equal to 0. I need to check whether that the given function f of x equal to absolute value of x is differentiable at x equal to 0. So I need to check the limit. That the limit f of x sub 0 plus h minus f of x sub 0 divided by h exists or not. So all what I need to find these things. I have x equal to 0, so I need to find 0 plus h is equal to, that will be, replace x by 0 plus h, that equal to absolute value of h. And also we have f of 0 equal to absolute value of 0 is equal to 0. So the limit f of 0 plus h minus f of 0 divided by h, where h goes to 0 is equal to the limit f of 0 plus h, we find is equal to h, so this is equal to absolute value of h minus 0 divided by h, where h goes to 0. And we know that absolute value of h is equal to either it is equal to h, this is f h greater than 0, and it is minus h if h less than 0, which means I need to find the two sides limits, left limit and right limit. From this one, I will find the right limit. So the limit of as h goes to 0 plus will be h divided by h. We just define this one as equal to h if h is positive or minus h if h is negative. And the right limit in this case, if h is greater than 0, it will be h over h, which is equal to 1. For the left limit, text is h, 0 minus, it will be minus h divided by h. And minus h divided by h is equal to minus 1. And it is very clear that the left limit and right limit are not equal. These are not equal, which means the limit does not exist. So this will give me that the limit of h over h as h goes to 0 does not exist. Now, if the limit does not exist at x equal to 0, this will give me that the function f of x equal to absolute value of x is not differentiable at x equal to 0. So the function is not differentiable at x equal to 0. But if we change the value of x, if we set that x equal to 1 or x equal to minus 1 or x equal to 10, it will be differentiable. But at that specific point, x equal to 0, the function is not differentiable. And the graph of this function, absolute value of x, take this shape. So at x equal to 0, we have corner. Any function has a corner, it is not differentiable at that point. So this is x equal to 0. And the function is not differentiable at this one, at this point. But any other point, it will be differentiable. But just at that point, x equal to 0 is not differentiable. Now, from the graph of this function, we can see it is very clear that this function is continuous, even at x equal to 0. So say in general, now, theorem, if function f is differentiable at x sub 0, then it is continuous. At that point. But the reverse is not correct. It means I can have a continuous function, but it is not differentiable like the example that we gave. Absolute value of x is continuous, but it is not differentiable. However, any differentiable function must be continuous. Any differentiable function is continuous, but not any continuous function is differentiable.